Hello and welcome to Technical Utkranti, and today we are going into the 12th part of the C programming series, and I'm sure that it will be of immense value to you. So let's get started. In the previous video, we looked into different ways of doing input and output with C programming language, and in this video we learn about the memory in the context of C program and brief introduction to the pointers. Let's get a brief introduction to pointers using a little bit of imagery. We have two images here, one of the variable a and another of the pointer b. A will always bring the data from just one address. It can also tell the address using the ampersand operator. And what is the data? This is directly accessible by this assignment operator. Variable is simple to use in the code. Coming to the pointer b, B can bring the data from any address the user provides, given that the address is valid. B stores the address, and using the star pointer, it can give user the access to the data. In this sense, B is more dynamic and sophisticated. B is the pointer. Now, few points to ponder here are: pointers provide access to data using address, which normal variables cannot. Normal variables are assigned the address by the compiler. So in the variable, you cannot fiddle with the address. You can only change the data at that address. But for pointers, you can provide them the address, and you can change the address as well as you can change the data at that address. So pointers are a bit more sophisticated and dynamic to use. Other use case of pointer is that they are very helpful in dealing with large data structures. Think about it, and if you don't understand it, we'll understand this concept in later part of the series. The only drawback with pointers is that it makes the code a little bit obfuscated. You can look at the meaning of obfuscated on the net and comment if you have time. In short, the pointers are needed to allow the data read write using addresses. Moving on, here we'll understand what is physical memory and what is virtual memory. Physical memory and virtual memory are not exclusive of each other. Virtual memory is the doing of the operating system. What I mean by that? As visible in the diagram, virtual memory is just an abstraction created by the operating system over physical memory, which could be, so the physical memory could be RAM, cache memory, hard disk, etc. But our normal program does not directly deal with the physical memory in case of general OS based machines. What OS does is it creates map of the physical memory to certain addresses, and these addresses are what program deals with. The program does not have to deal with direct physical memory. So the address which the program deals with, or the group of address which the program deals with, is called the virtual memory created by the operating system, and these are mapped to physical memory. For example, let's take an analogy of the parking area. It is a physical concrete thing, but when it is divided into slots, it is easier for drivers to understand where he has to go, like in slot 8 or slot 9, right? So that's how the physical thing is being used by creating an abstraction over it. Physical memory like cache memory, RAM, hard disk have varying speeds and size. Operating system does various kinds of optimization on the physical memory depending on the current application and need. OS moves around data in the physical memory during execution. So as you can see that physical memory is being completely dealt with the operating system. This is also called the memory management function of the operating system. In the earlier systems where operating system was not so frequently used, we had embedded processors which were doing very specific tasks, and they did not have operating system, so they dealt directly with physical memory. The code over there, uh, which was used by processor, and that processor was directly dealing with physical memory. So those were called embedded processors, and they are not very frequently used in today's world. I am putting a link of a YouTube video in the description which will explain these concepts in greater detail. Let's move on. So physical memory is just the sum of all the memory components like cache, RAM, hard disk, etc. etc. A 32-bit operating system would allow the processor to access the memory space of 2 to the power of 32, which is 4 GB. For Windows, it is around 2 GB, and for Ubuntu, it is around 3 to 4 GB. So what I meant was less than 4 GB. If the operating system is 32-bit, then the virtual memory could be a maximum of 4 GB, and for Windows, it can be around 2 GB, and for Ubuntu, it is 3 to 4 GB. Usable parts of virtual memory is called stack and heap. Stack and heap are further abstraction over the virtual memory. Just like virtual memory is the abstraction over the physical memory. Okay, now let's come to variable addressing. So normal variables have addresses. Using pointers, this address could be accessed and used to access the value at that address. What I mean by that, let's look at an example. I have an integer variable I whose value I have assigned as 10. I have an integer pointer, and using this ampersand operator, I am putting the address of I into this pointer variable. Now, I can access the value at this address by putting the star. So this is called dereferencing the pointer. Let's look at what it prints. So as you can see, it has printed the value of 10. You can do more experimentation with this simple piece of code. Accessing data using pointer is called dereferencing the pointer. So this is an important terminology which you should remember. Also, there is one special class of pointer which is called null pointer. So you can write this as null, and it points to nothing. If you try to access this pointer, it will not execute, as this address does not exist only. Let's see. See, it has got hung over here. Okay, so that was the null pointer. It does not point to anything. Coming back to our slides, so variable had addresses, and we saw how pointers could be used with variables. On the other hand, register variables, which store data directly into the CPU register, don't have address. Constants, literals, preprocessor directives, expressions, all these all these will become the part of instruction. Instruction can have the address, but the part of instruction cannot be atomically addressed. They will not have any individual existence as such. They will exist as part of instruction. Therefore, these does not have any address. I hope the point was clear. Okay. So we will close the video here itself, and we'll have a greater detail, in-depth look into pointers in part 13 of this series. Thank you.